Okay, thanks everybody. Welcome back to another OpenShift Commons gathering. Well, not a gathering, sorry, we had that last week, but back to our community calls. And thank you, Stephen, for being here. And if you can just introduce yourself quickly and
Sure.
go ahead, I'll hand it over to
Yeah,
you. Thank you.
yeah, sure. Stephen Wilson, storage architect here, supporting most of our products, but primarily focused on Red Hat Ceph storage, Red Hat OpenShift Data Foundation, and I do some work in Red Hat OpenShift virtualization as well. So yeah, let's go ahead and get started. So today we're talking about Red Hat OpenShift Data Foundation. We're going to do a review, and as we go through these slides, I'll be introducing and talking about some of the best practices involved with OpenShift Data Foundation. This is a subject we've been wanting to present for a while, and we're glad we have the opportunity to do it. All right, next slide. All right, so today what you'll get is a review of the basic concepts of Red Hat OpenShift Data Foundation. We'll review the architecture. We'll talk about the ODF configuration, as well as the deployment. We'll look at investigate the local storage for a lot of you all that want to provide a back end to the Red Hat OpenShift Data Foundation, as well as how to basically manage ODF. And then we'll talk about some monitoring. And along the way, we'll be talking about best practices. So get your pens out. For those that may be running or doing other things, of course, this will be recorded so you can go back and take notes as necessary. All right, next slide. Let's jump into it. All right, so some basic concepts concerning OpenShift Data Foundation. So what we have here is we're trying to provide you with consistent and highly available storage to support your Red Hat OpenShift workloads. We provide drivers that allow you to dynamically provision your storage, as well as we provide access to some shared storage. And then we allow you to have object storage also. So we provide 3-in-1 for your for the various type of workloads that you may want to put on OpenShift, and we provide that now. There are two modes that we'll talk about. They're internal and external. So a best practice tip here is to identify the workloads that you have when you come into ODF, because sometimes ODF may be a little bit too much for you, but sometimes it may be the exact tool that you need to provide the workloads, especially if you have mixed workloads that maybe need a shared file system, block storage, as well as object storage also. Next slide. So this is a review of how we provision this. What we do is we provision our storage, and this is important here, on top of other storage. So how that helps you out, the business value, is if you're in a cloud provider and you're paying for object storage and you have 1,000 PVCs, you're going to be paying for all those PVCs. Whereas with Red Hat OpenShift Data Foundation, we provision our storage on top of the storage provider, and you may will need a minimum of 3 PVCs within your OpenShift cluster. But inside of OpenShift Data Foundation, you can provision as many PVCs that you need, but you're only still paying for 3 PVCs. And as you scale out, you'll be paying for those individual PVCs that you provision against the storage, the cloud providers storage interface. But you can have as many PVCs internal to OpenShift that you would like, and you won't incur any cost. All right, we can go back. So setting the foundation here. Again, we said we support a variety of workloads, and many other storage providers on the market. Either they provide only 1 or maybe 2, but we're providing 3. So we're providing block storage. That's basically attaching hard disk to your workloads. Now you don't get to get in there and start formatting disk and like you would a traditional drive, but you do get an interface to a file system that's on that block storage, or you can have the block storage provided to your workloads, but we're not letting you go in there as a route that's for your security minded people. So you shouldn't be concerned about that. The object storage we provide for your videos and data archives, as well as some large objects that you want to share across your enterprise. And then our file storage, really, we just market that as the shared file system for your workloads needs. And we try to put that on things like the registry, as well as other things that we try to provide you that shared file system for, as a replacement for things like NFS and other shared file systems. All right, so reviewing the architecture. So it's we break ODF is really broken up into three components. The Red Hat Ceph storage, which is provided for your storage needs, and that's the primary work engine of your storage. But that's orchestrated by a project called Rook, and his website is at rook.io, as you can see here. And it's the orchestrator for the Red Hat Ceph storage. And then we also have another tool on top of that called the Multicloud Gateway, more commonly called Nuba, and it provides us the object store that allows us to uh, um, either replicate or mirror or share backend S3 buckets and provide one single interface to our OpenShift workloads for S3. All right, we continuing on. And this is a good overview. Now, one thing I'll stop here to talk about, we did go through a name change around the 4.8 to 4.9 iteration, and we changed from OpenShift Container Storage to Red Hat OpenShift Data Foundation. And so you will still see a lot of artifacts that refer to OCS as the backend. It's not a new product. It's actually the same product, but we just thought it would be better understood as the foundation for your AI workloads, and so you can put it into your have a better understanding of what role it plays in that stack there. So looking at this picture right here. So on the bottom, we come in and we have our availability zones. Now this is a best practice here for you to understand your own failure domains, and that question should come to you as, what entity within my infrastructure can I lose or replace and have the smallest impact? Although we sometimes try to do it with rack, and we sometimes try to use it with just server or host or node, but we also have availability zones that we can set at the regional level, at the area level. There are different failure domains, and that's something that you should come up with to say, the resiliency that I want to provide, how do I want to break that up so that if one piece goes out, it doesn't affect the other pieces. And again, as we see here, our minimum failure domains that we recommend is 3 failure domains. The question will come, well, can I do 2 failure domains? Can I do 1 failure domain? Really, if you want to do 1 failure domain, then Red Hat ODF is probably not the product for you, because we're here to provide you with the data resiliency that you need. And if you're doing just 1 failure domain, you probably would want to use another, just the standard CSI driver that comes in your OpenShift and whatever it's running on top of, because you're gonna not experience the resiliency that OpenShift Data Foundation provides for you. And the other thing is, 2, we do have that option for an availability zone or failure domain or replica factor of 2. That is an option, but we would like to have that on really highly resilient storage behind Red Hat OpenShift Data Foundation. So this is a great picture to describe how things are broken up into different availability zones. This is particularly in a cloud environment. Next slide. And so when we have our storage provision, what that looks like is we end up providing you with a CSI driver that allows you to do your dynamic storage and make your API calls to request for storage based on that storage class that we have. And so we expose block file storage, and then we use object bucket claims to provide you with the S3 object storage. This is a great picture that shows you the role that the CSI plays in provisioning your storage for you. Okay, next slide. And so this is a flow chart showing how the storage is provisioned. A user would come in, or a developer or an administrator comes in, creates a PVC request, and then the system goes and binds that to a PV. And then, of course, in the background, Rook is paying attention, and then it calls the system and creates the PVC and attaches it to Ceph, and creates a Ceph RBD or a directory in the Ceph FS file system, and then it provides you with that PVC so that you can use. Now, the thing here is to realize the storage classes are the key to the interface and what you want the backend storage to perform for you. So there's things like reclaim policies and things like whether it's you want to reclaim that PV or whether you want to retain that PV when the PVC is deleted. All right, next slide. Okay, so now we're talking about the architecture of Rook, and this shows you how Rook interfaces with the Ceph storage that is behind it. And this is the key thing to remember, is that the Rook automates deployment and the bootstrapping and the scaling up. So you're going through the Rook CRs to perform the maintenance on Rook. Now, a good tip to use is if you have issues and you're investigating some issues and you're looking for your initial investigation artifacts, go check the Rook project out, look at its GitHub issues and see if somebody else has had this issue before, and it might lead you in a direction to help you deal with this event the particular event that you're having. That is a good resource to use, as well as our own knowledge base and our own KCS articles. But that is a good point to look at, as well as if you want to interact with the end result of what OpenShift Data Foundation is, you can participate in the Rook project. Next slide. So with that, we're going to briefly talk about the Red Hat ODF architecture. So what we do in ODF, of course, the ultimate backend for the storage with ODF is Ceph. And so what we do is we create OSDs, which are simply your devices that you store data on, and the monitors keep track of all the information that's within the storage cluster. And then we also have managers that gather your metrics. So you see here, as the definitions point out on the screen here, that we store data on behalf of the Ceph clients, and the Ceph clients in your particular case with Red Hat OpenShift Data Foundation is the OpenShift cluster. And additionally, it utilizes it balances all your writes across all the a minimum of 3 Ceph nodes, as well as your monitors maintain that information and track that for you. And then your manager is what keep track of the metrics involved in that. So the things that eventually show up on the dashboard, that is what's communicating with the OpenShift dashboard. All right, Karina, do we have any questions or any comments? Anybody would like to have any input at this time? I'll take a break here to allow for that.
I have a question, but I'll save it to the end.
Sure. Oh, that's great. Fine. Anybody else? Floor is open. All right, like we say in our business meeting, hearing none, we'll move on to talk about the ODF architecture. Now, this is a great piece right here because it shows the role that Nuba plays in the orchestration of multi-cloud environments and access to the S3 buckets. So as this diagram shows, we have an OpenShift cluster that communicates with Nuba through the S3 API, your S3 commands, your get puts, deletes, and all those. And what it does is orchestrates the writing of that data, as well as the reading of that data also, to another S3 bucket that's stored on your cloud provider or on your on-premises environment. But what that looks like to you is you get a URL that has the access to the buckets, and you write directly to that URL that's referenced from the OpenShift URL, just like any other OpenShift workload. And it goes and writes that in the back end for you across AWS, Amazon, Azure. I said AWS and Amazon, but your different back end providers. Now, one best practice here is what we currently have now is we have a Postgres database that's running to support the Nuba workload. So a best practice is here now is once you have your environment up and running, you should take constant snapshots of your Nuba database, as well as the secrets and config maps within the OpenShift storage namespace, as they're very important. So in case you have an event, then you can more easily recover if you have artifacts to pull from, because if not, then you're going to lose a lot of information concerning your buckets. So just keep that in mind, that is those are resources that you want to back up. And currently right now, what we have is one instance of the Postgres database. In 4.16, we will have the option to store that Postgres database on a cloud provider or on an external database. But currently, that's something that we need to you need to be taken in consideration and accept the risk that, hey, if this database goes out, then it can cause an issue with access to those S3 buckets. So keep that in mind, that that is something that you want to constantly monitor and take backups of with some tools like OADP or some of the other tools that you may have. Remember, the OpenShift storage namespace is where those artifacts live. All right, so let's move on to the next. We have two modes of internal deployment. We have two modes of deployment for Red Hat OpenShift Data Foundation. We have an internal mode, which basically what that provides you is an internal Ceph cluster for you to access and use for your workloads. We also have an external mode that allows us to access an external Ceph cluster. Now, one of the things that we like to do is just say it simply that with Red Hat ODF internal mode, we don't want you to have to require storage administrators to orchestrate and manage that internal Ceph cluster. So a lot of features that you would have in an external Ceph cluster, although they are available inside your internal Ceph cluster, the operator can sometimes come back and reconcile things that you may have changed, on that internal Ceph cluster. So it's best to just do the deployment and use the tools that are available, the PVCs and the PVC YAML manifest, but going behind the curtains and starting to tinker with settings and ratios, that can get you into some trouble, because again, during an upgrade, the operator may reconcile the storage cluster and remove your customizations, and it could cause you some events that you would not want to happen. Now, on the other end, with the external, you do have that freedom to make those changes for that you may want. Now, another best practice here is just to respect the system. This is for simple workloads for providing block, file, and object. You can get yourself into some trouble with some advanced configuration, and then you would really need a storage administrator for. So keep that in mind when you're deploying these workloads, because you could do things and basically cook something up to provide you the storage and the infrastructure that you need. But you should be concerned that in the event, in the instance that you have an event, you may need some support exceptions, or you may have to deal with support, and they may say that that's an infrastructure that we haven't tested. And it just may take time to resolve, because the person may have to take time to actually understand the environment, and of course that's impacting you, because that time is maybe a part of an outage, and it may be ultimately affecting your end users. So keep it simple, deploy the system as it is. It's going to provide you the storage that you need, and if you need anything advanced, then consider the external mode. Let's move on to the next slide. The external deployment is what we talked about, and this is where you have the availability to attach multiple OpenShift clusters to this external Ceph cluster, as well as do some of those more advanced customizations that you may want to do. Let me grab here, make sure. And then also in this, remember, although you can simply set up with the help of our professional services, for some advanced customizations, you may need a storage administrator, but then you also could rely on our professional services to come in and help you out and manage that environment. Also a nice tool to have, especially for our enterprise customers, is the TAM. That's readily available to help you address any situations that you have, and is your ticket to inside resources that we have available for you. All right, next slide. All right, let's talk about the deployment. So in here, we're going to the deployment. This is the minimum requirements for deploying the Ceph cluster. We definitely don't recommend you implement this type of sizing in your production environments or your pre-production environments, but definitely for a lab, if you want to kick the tires and check things out, this can help get you going and deploying a simple environment for you to test and validate your use cases against. All right, next slide. So with that, what we deploy is we're going to end up deploying three operators: the container storage operator, the Rook Ceph operator, and the multi-cloud gateway operator. And we'll start going through these slides a little bit faster here. Our next slide deals with Red Hat ODF deployment. Let's show that slide, Karina. It's the next slide there. And what I have here highlighted is the failure domains that we talked about earlier. You notice here I have those highlighted there in the red box. And you notice that they're in three different zones here, 2A, 2B, and 2C. Now, what would happen if I had everything in 2A and there was an outage in US East 2A, then that would take down your entire ODF cluster. However, if you did lose zone A, but you still had resources in 2B and 2C, your cluster would still be functional. Now, also, I have three here, but as a best practice, if your minimum is 3, and I'm going with the minimum here just to show you a foundation, if your minimum is 3, put it in your mind to set your minimum to 4. That's a good practice, especially for some of our OpenShift virtualization customers. Go ahead and set that minimum baseline to 4 failure domains and 4 a minimum of 4 nodes if you're just really doing hyper-converge, so that if you lose one, you still have your 3 copies and your cluster wouldn't necessarily go into a degraded state while you have an outage of one environment. In this case, if you did have an outage of one environment, then you would only have 2 copies of your data that would be being stored for you or written for you. And then the cluster would indicate that it's in a degraded state. It would still be functional. However, you would still be operating in a degraded state. If you have 4 and you lose one, the cluster would recover, and then it would eventually come out of a degraded state. And then you have time to repair yourself and bring it back into a healthy, okay state from your monitoring. Also, another best practice here is labels. A lot of people go and have custom labels for their storage cluster, and then when we start isolating our workloads, we have to do the tolerations with all these different labels that we have, as well as we have embedded in some of the ODF operators and schedulers a custom taint already. And so with this label here, cluster OCS, OpenShift.io, OpenShift storage. So if you taint your nodes with that, that's the add your tolerations to your workloads for that. That's what you want to use. You have the option to set custom taints and as well as use a custom label, but then you have to make sure that you go into the subscription, you go into the operator, and you make those changes to say, hey, this is the actual label I want to indicate with my nodes. So keep that in mind, and I would just say keep it simple. Use the label that we already have embedded in the system, and then you should be fine. As well as add these taints to your machine sets and your bare metal nodes that you want to preserve for ODF, and then the system will automatically tolerate those, and you won't have any non-schedulable events that you'll see when you usually have those custom taints. This is a big one right here. It causes a lot of installations to take longer than what they are when we start using these custom taints and these custom labels, but keep it simple and your installation should just go smooth. So let's just run through the ODF installation. Whether you use the UI or the command line, you basically create a namespace to store your ODF artifacts. The next screen, Karina, I'm sorry. Create a namespace, maybe a namespace for your monitoring to show up. Sometimes in previous version, some of the metrics did not show up in OpenShift console, and that's because the label on the namespace was not set. But I think since maybe 4.12, we have not had to do that. But if you find that your some metrics are not showing up in your console, go ahead and add that label to the namespace and you should be okay. All right, next slide. Again, installing the ODF here, I have it referred to as OCS. And then you can just skip through these slides right here. There's quite a few. And when we share this out, this gives you step-by-step instructions for how to do it. The next slide, please. Next slide here again. Yep, and we can keep going on to right here. So go back one time for me, Karina. Right here. Remember to select a minimum of 3 nodes that are dedicated for OCS. But remember earlier we just said let's have a practice. A best practice is to do a minimum of 4 so we can have some resiliency in the event that we lose one node and the cluster is able to rebalance for us. Then go to the now we can go to the next slide here. This is one thing I wanted to talk about. To take note of, this is for your security team. The system is validated based on the FIPS validated based on the system that it's running on top of. So if your real OpenShift has not been installed with the FIPS enabled inside the install config.yaml, then ODF is not going to be validated for FIPS. So it's dependent upon the underlying operating system, which you can set that and when you install OpenShift. But if you don't set that, then you cannot say your ODF is running in that particular mode. Another note is data is encrypted when it is written to disk and decrypted when it is read from disk. Now we do have settings for encryption at rest, and we do have settings for encryption in transit. But there is a penalty. So best practice is to, in your labs, deploy it with both. And based on your security policy, take a look and see if you're willing to suffer that impact that will have, whether it's data in transit or whether it's the data at rest. The biggest impact that we've seen is the data at rest has not been so much of a problem, but it's the data when we're in transit. We've seen an impact on that, as well as if you already have encryption, that may be something that you don't need to enable inside of ODF, but may be able to enable in your backend storage. As well as now, when we set the mode for encryption at rest, what that does is if you don't have an external key management store, then it basically encrypts your keys in Red Hat OpenShift secrets. Of course, we know those are base 64 encoded, and if that's fine for your security posture, then go by any means. That's fine to use. But if you have a slightly higher level of requirement, then HashiCorp Vault is available, or another IBM system key value store that we can use to store those artifacts in. So, okay, if you really have sensitive workloads, use a tool like HashiCorp Vault to support your key value stores for your Red Hat OpenShift Data Foundation PVC encryption certificates. And we also have the feature for encrypting PVCs. But again, it goes back to what your security requirements are. Take a look and see if you are required to not use base 64 encrypted secrets, then you want to look at an external key management store to provide that security for you. One thing to take a note of, just in case you have to report, key size 512 bits. We're using the AES XDS Plain 64 cipher, and the keys are stored using a Kubernetes, like we talked about, Kubernetes secret or an external key management store. So when your security team comes and asks you, hey, how are you managing the keys for this system, then you can provide them with that answer right there. And then we have links to the documentation concerning that. All right, next slide. Next slide was just going through the ODF installation. And at the end, we'll have 4 storage classes available to us. Let's go back. We'll have the RBD, which is your block devices, the shared file system, as well as access to Nuba for our object bucket claims. And then we also have this one right here, which this is a best practice tip for us to take care of. Sometimes Nuba may not provide you the, especially with the Postgres database, one Postgres database that we currently have. So you may want to take a look at and use the RGW object bucket claims to provide you the S3 storage that you need. Now, the only time you will not see the Ceph RGW is in an area like Amazon where it's not automatically deployed, but you can go back and you can redeploy that using the Ceph Object Store CR. Next slide. All right, with that, let's take a pause here. We got any questions from the team or any comments or thoughts? If I need to slow down, slow down. If I need to speed up, let me know.
Hello, can you hear me?
Yes, sir. Hey, Benjamin.
Hey, how you doing?
I'm great. I can't complain.
Yes, yes. Is there? Do you have any type of guidelines as to the cost of managing these things and trying to get a customer set up with the options, or how much? I think you did go over how much data, but with all of the, some customers may want the bare metal of everything to start off, and then you tell them, well, this is what you need for the maximum redundancy.
Yeah, for the cost, of course, that's going to be dependent on your back end. If it's bare metal, is whatever cost you have invested in those particular bare metal resources. Of course, if it's one of the cloud providers, and you'll be incurring those costs. But the point that I was making earlier was, if you were to have workloads, say you had 1,000 workloads on OpenShift, and you needed persistent storage for those 1,000 workloads, that would require you to have 1,000 PVCs. And a lot of cloud providers don't care. They either charge you by the number of PVCs, regardless of the size, and then you got bursting and speed and all that kind of stuff that you also have to pay for. So those are considerations for you. But with OpenShift Data Foundation, you would have a minimum of 3 PVCs that you would actually be paying the cloud provider for, or if you were using bare metal, just a minimum of 3 hard drives. Don't tell anybody I said this, but a minimum of 3 hard drives to provide your storage for ODF to use, to carve out of, and then you could have those 1,000 PVCs going across those three storage devices. So it becomes in your cost analysis, do you want to pay for 1,000 PVCs, or do you just want to pay for 3 PVCs? Does that help answer your question, Benjamin?
Yes, it does. Because you hear about all of these LLMs and large parameter LLMs. I'm like, wow, that's gonna be a lot of data all over the place. And and in some cases, it's looking like HPC is becoming distributed because some people want to do the GPU here and do the CPU here. And in my mind, I'm like, how do you keep track of all of that? And I'm just, does that require different storage for this or that? And in my head, it's just spinning. And I'm like, is there best practices for those things too?
Yep. And so, and just like you said, especially if you have AI workloads that really are using ephemeral storage, they just need some quick storage, and then they're going to get rid of. Well, if you provision that PVC against a cloud provider, you're going to still pay for that. Whereas if you're using something like ODF, and remember, ODF is not the only tool in this market, but if you're using a tool like ODF and you provision a PVC and then you delete that PVC, you haven't incurred any cost on your side. All right, so we'll run through local storage here really quickly. The point about local storage is to remember, if it really only works for those environments that there's not a CSI provider for that storage backend. But so this more comes into play when you have bare metal instances. You're going to need the local storage, but it also comes into play if you're in a random cloud provider that does not provide a CSI driver for its backend. Then you would be relying upon the local storage operator. So these are your SAN devices that are behind. These are some of your other types of arrays that you may have behind you that you want to provision storage from. And then remember, you have to do a risk assessment and see where you want to accept your risk at as far as fault tolerance and encryption and things like that, and how that plays into the system. So with this is for using local devices. Like I said, we'll speed through this right here because this just talks about the configuration for you. But the key point to remember is to use the local storage operator to provide PVs that ODF can use on your for its PVCs or for its OSDs to provide the storage for that. The key slide here is I wanted to go over was we can go to the next slide, Karina. Next slide. This is just the installation. Here is one. So this is what it looks like on a node. And so in this case right here, we have these nodes available to us, like the NVMe drive we have available to us, and that's a node that we will use. Now, when we're deploying these, and many of you may already have experience with this, you can deploy these with a local volume set or just a local volume. the local volume set is relying upon the auto discovery daemons that run across all the pods. But if you want to use the local volume option, you can use instead of using the common names like dev SDB, SDA, SDC, use the either the UUIDs or the worldwide IDs, so that when you're swapping these things out, you don't get caught up in something not being properly named, and then you have to troubleshoot that. But there's the dev disk and by ID or by UUID or by worldwide ID. Use those as opposed to using SDA or SDC and SDV. Well, I've seen a lot of people have outages and have events because they'll reboot their OpenShift infrastructure node, and then the drives come up with a different naming scheme, and then it causes an impact because things start shuffling around automatically. Whereas if you're using those unique identifiers for those hard drives, when the system comes up, it'll always know its place in the system. Key point to remember there. All right. The next one here is we talked about the node selector terms. So when this is a good practice here is to, when you are using your local volume or your local volume set, only scan the systems that you know have your disk. If it's constantly scanning all your nodes for these disks that may be available for storage, those are resources that are being consumed. So use the node selector and say only scan these disks with these labels, and then you'll be fine. Of course, you can always use a custom label like we talked about before, but just go ahead and use the custom label, the label that we have hard coded in our ODF resources, and that way, once you label them, everything starts falling into place, and you don't have to start editing config maps and adding overrides to say use this toleration as opposed to in addition to other ones. And then, of course, down below, it shows you the device paths to use. And, of course, this one has that unique identifier for those respective disks. So key point is only scan the nodes that you know have the disk that you want to be used for ODF. Because one thing could happen is you could scan a disk and it starts using disk that you don't want it to use if you're scanning your entire OpenShift cluster. All right, and of course, in here, if you you could also add your taints and tolerations if you have your infrastructure nodes reserved and are using those infra tolerations also. All right, so we move on to managing ODF. You can scroll down. I'll take a pause right now for any questions, concerns, or thoughts. All right, moving on to managing ODF. We'll just go through these slides right here. This is an example for using ODF to manage the registry. Remember, we have the block, the shared storage, and the object storage. Our best practice is to either use the shared storage for this, because of course we have the multiple nodes inside of OpenShift with the registry, or use object storage. And you will also find, and this may be confusing for some that have been reading our documentation, in one version it may say use object storage, but the next version it may say use Ceph. Install in the lab, see which one works best for you, and then you make your decision, off of that. But definitely don't use block storage unless you have a single node OpenShift cluster, which this is not going to work on anyway. That's a joke. All right, so this is an example of the ODF image registry. The next one we have here is to look at the monitoring that we can when we're editing the for the workload, the monitoring workloads. Now, in here, we use block storage here. Is recommended for the monitoring stack. Now, in this is a key point also to tell your developers or your end users is to always provision and request your storage with a storage class name. A lot of people just say, I'm going to request storage and I only want 50 gigabytes or I want 200 gigabytes for this. But then what happens is it's going to use the default storage class, and that may be the cloud provider storage class. So then you look up and now you've got 1,000 PVCs off the cloud providers, and then you're paying for that. So you can either go back and set the default storage class to your preferred storage class within ODF, or you could always request, having your policy that, hey, whenever you're requesting storage, you should have a notation in there to say, I want to provision storage from RBD. I want to provision storage from Cephfs or any of the other storage classes that you may have available. Because if not, you may end up using storage that you don't want to use. One example that I've seen is we have a KCS article that says databases, we don't want you to use databases on top of Cephfs. Well, this particular customer did not have the storage class in the request. So for some reason they put Cephfs as the default storage class. And so when their database workloads, all their workloads was requesting storage, it was using all Cephfs. And then some of the issues started happening where we have documented in that KCS article. So remember to either set the default storage class to your desired storage class that you know your workloads are going to use, or always set it in your PVC request inside your deployment or stateful sets manifest. And I would say go ahead and establish that as a policy so that your developers and your end users know that when they submit these manifests to the pipelines, that it has to have a storage class name that it's going to use. Save you a lot of headache. All right, next slide. Again, this is another one for the login stack here. And then we can do a next slide. Now, this is about scaling up the storage nodes. Now, we've always said that when you want to scale up Red Hat OpenShift Data Foundation, what you start with is the same level of scale that you have to go on with. Save yourself some trouble and keep that rule. There are options to scale up individually, scale up by disk, and scale up. But what usually happens is customers end up imbalancing their clusters, and then they have an event. And then with the cluster being in balance, one node or one failure domain takes out more of the cluster than expected, and then it causes a significant issue. So keep in mind, if you start with 3 nodes, scale up by 3 nodes. If you start with 3 disks, scale up by 3 disks. Don't get behind the scenes and start trying to fix the system to say, okay, I only want to add 1 disk or I want to add 1 device set. You can, but what will happen is you will start ended up putting the cluster in an imbalanced state, and then that could cause you some issues later on. So you can kind of keep that rule that if I start with 2 gigabytes, or if I start with 4 terabytes or 2 terabytes or 512, let me scale up by that same amount. And also one thing, when we're doing our size, and use our tool, the OCS ODF sizer tool that's available in our access.redhat.com, and get you a good foundation for your size. Because although you can scale up when the cluster starts getting full because you haven't properly made considerations for your initial size, it's not, and you're continuously writing to the cluster, it's not going to wait for you to go order hardware. And if you get to an event where your cluster is full, then you'll have to call support, and they'll help you out in that situation. And also remember, there are some parameters. Your cluster is not going to wait till it's 100% full. With ODF, it's going to wait till it's 85% full. And then it's going to give you a warning at the 70% mark. I think it's the 70% mark to say, hey, you need to start considering scaling out your cluster because I'm getting a little full here. But even when you see those warnings, you have to remember your failure domains have an impact on you also. So if you've not properly balanced your cluster, what could happen if you have an event, one node or one OSD for that matter could cause a event in your cluster, because if you lose one and then it starts fixing itself and rebalancing, it could cause the other disk or the other nodes to become full itself. So usually you want to around the 60% mark. You can write that down as a best practice. 55-60% mark, you need to go ahead and start making considerations and putting your change request in for scaling out the cluster. So like I said, don't wait until the warning, or if you did, once you see the near full warning, you want to go ahead and start scaling that cluster out. Don't wait until you see, okay, the cluster is full before you have a problem. So keep that. That's the best practice to always keep in mind. And after you pass that 50% mark and you should start being concerned about the 60% mark, then you need to start looking at scaling out the storage cluster, especially in the hyper-converged where you don't have a lot of resources. One node going missing could cause significant impact. So if you look at that, if you have 3 nodes, that's like 33% of your data. You lose a node, you lost basically 33% of your data, and you also have to recover that. All right, any questions around that section there? All right, hearing none, we'll move on to the next one, the object bucket claims. This is the interface for creating your object buckets. And now what this will do is give you a route to, you'll have a route and you have an access key and a secret key to your bucket. And again, you can use the Nanuba route, or you can use the S3 route to provide your object bucket claims. To provide your S3 object storage for you. So even now with the OpenShift logging and some of our other, the Loki stacks that are available out there for us, you can use the object bucket claims to provide that storage for you. All right, and remember what I said, constantly take a backup, or at least at a minimum a snapshot of the NubaDB and the config maps and secrets within the OpenShift storage namespace, so you can, more easily recover. Now, after the event or slightly before your snaps, you may lose some things, but if you keep up to date with it, you should be fine. And remember, snapshots in ODF, they're not going to cost you anything. It's a simple snapshot for you. And there, one thing that I may have forgotten to mention is all this is thin provision based upon the backend storage. So if you are on VMware, for example, and you have your policy set for thick provision, lazy IO, or something like that, when ODF requests that, it's going to actually request the, excuse me, the 2 terabyte disk. But if you have your policy set for thin, it's only request it's only going to request and use what it actually needs. So that can save you some space there. But don't play the game of, well, since everything is there in provision, I can over provision for my storage. If your storage is on there with other workloads, let that storage be, instead of playing the shuffling game because everything is there in provision. That can cause you some issues also. All right, next slide. And I've given you some examples of how to deploy some object bucket claims and what that looks like. All right, monitoring ODF. We got one screen here, and then that'll be it for us. And I'll open up the floor for questions. Not that screen. Monitoring Red Hat ODF. This is an example of the screen. We have more features than this screenshot from when I had this image here. We now have an ODF topology view that you can see how your nodes are laid out. But this gives you a good example to monitor, as well as some of the other metrics that we have in the Observe tab inside of OpenShift. So just always monitor yourself, set up your alert manager to properly alert you when you have events. And this is what we have. Now, some people will say, okay, well, the storage dashboard is available in the Rook project, but I enabled in the storage cluster CR, I enabled the dashboard, but it didn't show up. That functionality is not available in Red Hat ODF. All right, and that's it. We can skip this slide here. That UI is not available for us anymore. And the next slide here is a great UI, but we'll open up the floor for any questions, and then I have a list of some other best practices that I had wanted to share with you all.
So quick time check. We have 4 minutes. We could try to run over a little bit, but we can always invite you back too. So sorry to jump in, and please, whoever was going to ask, go ahead.
Yeah.
Hey, this is George. Usually there's like a little raise your hand thing, but I didn't see it. But anyway, this question is more about general storage around OpenShift virtualization. I'm on this ecosystem solutions architect team. I work with Pure and NetApp.
Yeah.
Who provide CSI drivers for OpenShift. And they're seeing, especially NetApp is seeing a lot of requests to use, not a lot of requests, but a lot of recommendations to use Fiber Channel with OpenShift virtualization. Is that something that you've seen? And is that a recommendation from Red Hat?
I've seen that. And what we have to do when you do that, make sure you talk with the customer and say, hey, these are your risk factors, and do you want encryption on the fiber the back end, or do you want your encryption in the front end? Do you want your replicas in the back end, or you want your replicas in the front end? Because like a lot of fiber channel devices that we have, they'll have their inbuilt replication, because definitely they wouldn't just go with one device, right? They would go with, I've seen a minimum of 2, but then the recommendation would be if you can do 3, that would be better, where you're pulling your PVCs for Red Hat ODF out of at least your fiber channel basically would become your failure domains. Because if you put everything on that fiber channel device and then it has an issue, well, then your whole cluster is going to be affected.
Yeah.
But that's something to think about, especially because that becomes a single point of failure, whereas the ODF would not be, because it wants 3 different failure domains. The other thing is if you have a replication factor, say you had a cluster set up of some type of device behind you, and then you're doing 3 in the back end on your fiber channel or whatever device that you have back behind ODF. Remember, ODF is going to do a minimum of 3 copies also. So any write that comes in, you're going to write 3 times in ODF, and then you're also going to write 3 times on that back end.
That's a lot of overhead.
Yeah. So that's why we had that replica factor of 2. But then you can also say, okay, I'm going to reduce the replication factor on my fiber channel, and then I'll just make sure everything is on the front end. And also, go ahead. I'm sorry.
Oh, no, I was just going to say, because this has actually come up a couple of times with the fiber channel and OpenShift virtualization. So I was just wondering if this was like pretty common, or if it's something Red Hat's recommending.
Actually, we have seen it quite a bit. I've seen it quite a bit, and I think we see it so much that we used to require a support exception for it, but I think now we support it through the agnostic development in the interoperability guide that we have. And so those are some of the things that I wanted to go over. Some best practices here real quick. Best practice, understand what is supported. And that was a great question that you just asked. Make sure you have the subscriptions, check with your account team, make sure that you have the subscriptions, because we do have 2 modes. We have the Red Hat ODF Essentials that get you some things, but then we also have the advanced subscription that gets you more things like disaster recovery features that we have, as well as some other options that may be beneficial to you. Take a look at the supported configurations when you're looking at your infrastructure. And we have KCS articles for that, and we'll add those to the
someone is at the front door.
Take a look at the supportability and interoperability guide to see the things that we have tested and that we said that we would stand behind. And if you don't see anything that's common to your environment, then you have the option to put a support exception in. Also, review the tools that we have. The ODF Sizer is a great tool to use to start setting your baseline for your initial deployment, as well as looking at the recovery calculator. That helps you define this to get metrics to say, if I was to lose this particular type of device, how long will it take for me to recover? And then you start having an impact, and gives you information and inputs for your RPOs and your RTOs so that you can give to your security team to make sure that you're meeting those requirements. As far as nodes, let's take a look and make sure that we're looking at, do we want to do reserved nodes or shared nodes with our OpenShift workloads, or do we want to have reserved nodes that's specifically for Red Hat OpenShift Data Foundation? We have two main best practices here. Is there either to use reserved nodes just for Red Hat OpenShift Data Foundation to provide your storage, or to use Red Hat ODF along with infrastructure nodes to provide those. That way, if there's anything going on with your OpenShift workloads, they won't impact your storage that other workloads may need. But of course, you can always share the nodes, and everything is fine. But with that, always label your nodes that you're going to reserve with the infra tag, and you should not have to incur any cost on those. Define your failure domains and install the system accordingly to your failure domains. The other one is investigate and understand the impact of each node's percentage of your storage, because we do try to say everything should be replaceable. So take a note of, okay, if I lose this node or if I lose this disk, what's the impact of that on my entire cluster? And then plug that into your recovery calculator, and you can see how the system will respond if you have an event. Impact of each failure domain's percentage of storage. So even if you have 3 nodes in one failure domain, if you lost all 3 of the nodes, that gives you input so on what happens if I lose that entire failure domain. Look at the CPU on your requirements for your disk, and also when you have bare metal, the impact of the NUMA technology, that how that can play a factor. SSDs are the only things that are supported, so always go with SSDs. Now, one thing to note is when you're deploying on a cloud provider or even on your bare metal, take a look at the disk and see if they come up as rotational or non-rotational. We only support the non-rotational, although you can install the system with rotational, because that can have an impact on your throughput and your speed and some of your latency. Respect the size of the disk that we have. We have a guide to say these are the disks that we support. Another best practice that we have is use multis to segregate the cluster traffic from your public traffic that's accessing the system. That's basically NICs for client traffic and storage traffic, and enable jumbo frames. And then also one big thing to that's a big best practice is have your backend cluster traffic network a minimum of 2 times your front end network. Also use the MON data host path to go ahead and store those locally, as opposed to provisioning PVCs for those. Those can go and come as long as you have you start with a minimum of 3, but they can go and come. But there's no sense in spending PVCs on those there, because they will provision from your cloud provider storage, and that's just less cost that you have to worry about. Some hard, remember the modes: read write once, read only many, and read write many. The replication factor consideration in your SAN, encryption, and best practice is after you install, make sure you know how to use the must gather tool should you have an event, because that's the first thing support is going to ask you for. All right, I hope I ran through those quickly and not too fast. Do we have any other questions? I think we're right at time.
Well, I think I think that's it. And we'll just have you back, and thank you again for
I'll be glad to.
being here. Very, very much appreciate it.
All right, thanks.
Thanks again. All right. We'll see you soon. I'm going to stop recording.